kids, Miss Kulkarni here. In this video, let's talk about structure of benzene. Are you guys ready? Let's begin. So, the structure of benzene was a big puzzle for a long time. Benzene, the molecular formula, is C6H6. It is very simple aromatic hydrocarbon. Now the word aromatic came from the word aroma, and most of the compounds had sweet aroma. Going back to benzene, the formula C6H6 was not able to give any valid structure using organic chemistry rules. But then there came a scientist and his name is Kekule. So Kekule proposed a different structure. He had a dream about the snake and biting his own tail. That's the story. But the main thing is he came up with a cyclic structure. And of course, people did not believe him in the beginning. So according to Kekule's proposal, there are two equilibrating structures. And they both have 6-member rings with 3 alternating pi bonds, and we'll talk more about pi bonds later. So look carefully. That's the numbering of benzene ring from 1, 2, 3, 4 going this way to number 6, and this is same one going from 1, 2, 3, 4 going to 6. Do you see some difference? The double bond here is between 1 and 2, 3 and 4, and 5 and 6. What about second structure? Look at that. The double bonds are alternating. Now they are between 2 and 3, 4 and 5, and 1 and 6. So according to Kekule, he proposed these structures are interchangeable, and these are called as resonating structure, and of course the phenomenon is called as resonance. Let's talk about some bonding in benzene. So according to Kekule, he said that the bond between 2 carbon atoms can sometimes behave like a single bond, and sometimes it can behave like a double bond. So how can we conclude what exactly the bond looks like? According to organic chemistry rules, carbon-carbon bonds are having a particular bond length. Look at that. The single bond will have a length of 154 picometers. A double bond will have 134 as the value. And what's the value which we got for benzene? This is 140. This is exactly in between those values for single and double bond. So what does it tell? That means the bond is neither a single bond nor a double bond. In fact, it makes the bond order as exactly average of both 1 and 2, which is 1.5. Alright, let's discuss more about the unsaturation in benzene. So benzene has 4 degrees of unsaturation. If you remember IHD, the index of hydrogen deficiency. How do you decide that? It depends upon 1 ring and plus 3 double bond, and that makes it as a 4. So benzene is pretty highly unsaturated hydrocarbon. And just to remind you, the double bonds are alternating their position, and that's called as resonance. Now let's talk about sigma and pi bonds present in benzene. It all depends upon how the s and p orbitals overlap. To make it easy, I want to tell you something, a secret. If it's a first single bond, usually that's going to be a sigma bond. And if it is a double bond, then that extra bond is a pi bond. And if it is a triple bond, then that is going to be an additional pi bond. So in benzene, we got single bonds between each of the carbon atoms, and also we got 6 bonds between carbon and hydrogen. So that makes it how many sigma bonds? We got 6 sigma bonds, and also we got 6 sigma bonds for C and H. Now coming to the pi bonds, the p orbitals are perpendicular to the plane of benzene ring. So look at that. This is our benzene ring and the pi orbitals are exactly perpendicular and they are of the shape looking like an hourglass or like just simple number 8. These pi orbitals, if they come closer, they can have an overlap, and if there is an overlap, then that results into a double bond. So how many of those double bonds will be present? At a time, we can only get 3 pi bonds because they will be between carbon and they will correspond to the double bonds between carbon and carbon. As you know, benzene has resonance structure, so the double bond keeps on switching. What does that mean? That means the pi bond overlap will constantly keep on changing. If I have got these numbered as 1 through 6 in this manner, I may have a double bond between 1 and 2 at a time, or next moment I can have a double bond between 1 and 6. With all this switching between the double bonds, the electrons actually revolve in something which we call as electron cloud, and we will get electron cloud floating on the top as well as at the bottom of the benzene ring. So this constant switching of double bonds make the formation of electron cloud on the top and bottom of the benzene ring. This electron cloud gives a different property to benzene. Now because of this electron cloud, benzene can undergo a reaction with electrophile. What is an electrophile? The word phile stands for loving. So it is any particular group which can be electron loving. Which group is going to love electrons? Electrons have the charge which is negative. So obviously electrophile should have a charge which is positive charge. For example, there is nitronium group which has a positive charge, and of course there are many more examples. So now you know that benzene undergoes electrophilic substitution, and you may think why benzene does not undergo addition reaction. Normally any unsaturated hydrocarbon like alkenes and alkynes, they will undergo an addition reaction. But even if benzene has these alternating double bonds, this reaction, which I am going to show you right now, will not take place. It will not give a dibromo compound like that. Instead, if bromine reacts with benzene, it will undergo electrophilic substitution in which one of the hydrogen will be replaced by this bromine. And we will find out more about electrophilic substitution in our next video. I hope you guys enjoyed the video. Until then, bye-bye.